Hey guys, today I'll be talking about hypergeometric distributions. Alright, so looking at the name, the first thing that pops out is geometric. We've learned about geometric distributions. There are no set trials, you go to the first success and stuff like that. So this must be similar, right? Wrong. In actuality, it's more like a binomial distribution with set trials, and you can test for more than one success. Alright, so now you may be wondering, what sets these apart from normal binomial distributions? Well, the thing that sets these apart is that there's no replacement, much like your dog, your best friend FN2187, and your firstborn child. Though after that, they're perfectly replaceable. In other words, the chance of success changes with each draw. Alright, so there are actually quite a few equations for this. I just picked this one because it's the simplest to understand. I have the variables x, big N, small n, and k. First, we'll start with x. X is just the number of successes you're looking for, while big N is your total population, small n is your sample size, and k is the number of successes possible in the population. Alright, so now that we know all this, obviously, next we have to do an example. So this is the example I chose. Might seem a bit long, but don't worry, I'll walk you through it. So your friend has 52 Ferraris in his Ferrari account. Half of them are pink and half of them are green. You've had some bad blood with your friend. After you took the stats final, you talked to him about it, and all he did was say, "You fool, that's wrong. You just lost points." At first, you were quite sad and cried yourself to sleep that night. However, in the morning, you decide that you want revenge for the pain he caused you. Therefore, you decide to steal 5 of his cars at a time. However, you only want to keep the pink ones. What's the chance 2 of the cars will be pink in a steal? So starting off, we see that your friend has 52 Ferraris, which means that big N is equal to 52. And then you see that you decide to steal 5 of his cars at a time, which means your sample size, or slightly smaller n, is 5. And then after that, you see you only want to keep the pink ones. And so you realize that half of them are pink. And so your k must equal 26. And finally, you just look at the question and it says 2 of the cars will be pink in a steal. And so the number of successes you want is 2. Alright, so once you plug in the numbers to your equation, it looks something like this. And then you just do the combinations and then you get some numbers that look like this. And in the end, you get that the probability that you'll steal exactly 2 pink cars in a 5-car steal is around 32-33%. So even though that was a great problem, it's not really realistic, and so I'll give you some idea of how this might be used in real life. Okay, so let's say you're playing poker with your friends or something, and you've got these two cards in your hand, and so that means you would want 2 more diamonds to come out, and you'd do a problem roughly similar to the one I just did. Okay, so let's say one of the cards down changes into a diamond, then instead you'd want 2 or less diamonds to come out, and so then you'd do something which is called cumulative hypergeometric probability, and well, it's basically the same as hypergeometric probability. So this is roughly what it would look like if you wanted 2 or less red cards to come out, and I don't have enough time to explain it all, but if you do a little bit of mental math, you'll see that it roughly comes out to about 90.72%. Now you might be wondering what the graph of the distribution looks like, but honestly I couldn't really figure it out at all. They all looked so different, and like this one even looked more like fine art to me now rather than a graph. So I mean, like, well, I guess if you figure out, just like call me or something. So that's all I got. Thanks for listening. I know that 5 minutes is quite a bit longer than my attention span personally, so yeah, thanks.